question number 20. The data in the table below shows the yearly salary of a writer T years after she started a job. Now assume a linear relationship between S and T. How much will the writer be making 11 years after starting the job? Well, there's an easy way to solve this particular problem. So I will do that, as well as just a proper way of figuring out the linear equation. And, of course, using that to figure out the answer. Because it's not every day that we're going to have questions like this that will essentially be easy to cheat in a way, which is what I will be doing right here. Well, it's not actually cheating per se, but well, I guess you will see. So here we have 4 years. So after 4 years, she was making $41,000. After 7 years, $50,000. After 9 years, $56,000. And after 11, well, this is a linear relationship, right? So between 7 and 9 years, of course, there are 2 years, and her salary went from $50,000 to $56,000. So how much will she be making after 11 years? $62,000. That's it. That is the answer to this question. Because there's a difference here of 6,000, and there should be 6,000 between 9 and 11 years as well. Just because between 7 and 9 there are 2 years, and between 9 and 11 there are 2 years. So this was the easy way, essentially. I hope it makes sense to you. If not, that's actually not a problem, since I'm going to solve the problem in a different way as well. A more logical, mechanical way. So that would be the answer right away, though. So let's confirm now with the actual proper way of solving this problem. Remember, y equals mx plus b. In this case, we have s equals mt plus b, because essentially the salary will be our y. So s is the new y, and t is the new x. T in number is the number of years, essentially, after this person started her job. Okay, so now let's use the slope formula to figure out what m is. And here we have T1, T2, S1, and S2. We won't need to use the last coordinate here, essentially. This can be seen as a coordinate, of course. So m is usually y2 minus y1 over x2 minus x1, but in this case, y is s. So we have s2 minus s1 over x is t, so we have t2 minus t1. So s2 is 500. Or sorry, no, 50,000. I don't know where 500 came from. S2 is 50,000. S1 is 41,000. T2 is 7, and T1 is 4. So 50,000 minus 41,000 is 9,000. 7 minus 4 is 3. 9,000 divided by 3 is 3,000. So that's essentially the yearly salary increase. Every year, her salary goes up by $3,000. Now, we have what? I actually meant to write S instead of Y. S equals 3,000 T plus B. Now, how do we solve for B? Well, I can just plug in 4 for T and 41,000 for S. That easy. Okay, because, of course, after 4 years she's making that much money, and since this data should fall, or this piece of information should fall into the equation of the line. In this case, we can just plug these numbers in. So 41,000 is equal to 3,000 times 4, which is 12,000, plus b. Then we can subtract 12,000 from both sides of the equation. Those cancel out. And b will be equal to 41,000 minus 12,000, which is $29,000. Okay, so we have the equation now. S is equal to 3,000 T plus 29,000. How much will the writer be making 11 years after starting the job? Well, to find out the proper way, I can plug in the 11 for T. So 3,000 times 11. 3,000 times 11 is 33,000. 33,000 plus 29,000 is 62,000. So that's it. So the long way was essentially the proper way to solve the problem. But of course, when we're given data like this, and we're able to find the answer quickly and cleanly, like we did over here, that'll be perfectly acceptable. But it's also great, or essentially necessary, for you to show your proper work anyways. So I would say, please be ready to answer the question in this way as well. Figure out the equation of the line, plug the numbers in, eventually the 11 in for T, to figure out the salary 11 years after the worker has the job or started the job. That's it.